tend to, students, some of these are super easy, but some of these are not at all easy, and people tend to clump them together and think they're all easy and take shortcuts, and then they miss problems that are just medium because they think they're easy. Anyway, my point is just do what I ask you to do. Don't take shortcuts, and you will succeed. All right, now the idea of the day is rules for definite integrals. Two of these you already know, the first two. And then we'll go on to new ones here. What if you are integrating and you have a coefficient in front of a function, like 3 root of? You can pull that out front. I am going to strip away the x dx's just for the sake of time again. What about if you integrate a sum? Can you integrate the two pieces separately? You can, okay? That is allowed to integrate f, then g. Is that allowed if you had a product fg? Can I integrate f and g? No, you cannot do that for products. We know that. All right. Now, some newer stuff, some of which, again, are super obvious and intuitive, some of them not so much. So, if you had an integral from a to a, what would it have to equal?
0.
0. Why? Okay, one way is to say because the antiderivative at a minus the antiderivative at a is 0. Graphically, you could say the area under a curve with no base is 0. Okay, either way, lots of good stuff here. Now you're going to need to put in a sign. It's incomplete here. The integral from a to b, how does it relate to the integral from b to a?
Negative.
It is negative because you just went backwards. Dx is negative now. You could also look at it this way. Say you went this side. Isn't the integral from a to b of f something like the antiderivative at b minus the antiderivative at a? Wouldn't you agree that's how I do that left side?
Yes.
Okay. Would you also agree that I could factor out a negative and switch the order? Antiderivative at a minus the antiderivative at b, yeah? Well, what about that inside expression? Isn't the antiderivative at a minus the antiderivative at b the same as the integral from, instead of a to b, from b to a? And so you can see then that when you switch the limits of integration, you're switching the direction of the dx, and it's negative. You follow? All right, this one also is super duper obvious. Let's do a picture here. The first region is from A to B under a curve. The next region is from B to C under a curve. What do you reckon that's equal to? The region from A to C. I could do the antiderivative work again and say antiderivative at b minus antiderivative at a plus antiderivative at c minus antiderivative at b. See the antiderivatives at b drop away, and it would become just a to c. And if you like, you can do that too. Okay? I am going to skip these. I'm going to do these in set 86. I was going to put them in early, but I'll just do them when they come to book. All right? Set 86, yeah, don't ask me why they come so late. It is what it is. You'll get to about set 103 in this book. Okay? All right, go to the next case. Bounded graphs. All right? If they give you a boundary on F, then they also are giving you a boundary on the area under F. A little something like this. Say I told you f of x is positive on some region from a to b. What would you know about the integral from a to b? It's got to be positive also. Now let's prove that. Prove why that must be true. Let's take what's given. F of x is greater than 0 is given, yeah? Mm-hmm. All right. Now, integration is just like all other math operations. Whatever I do to one side, I have to do to the other. So if I want to talk about, hey, what's going on with integrals, then I need to integrate not just the left side, but also the right side. Now, that's cool. The left side is what we're trying to make a conclusion about, but the right side is the area under the 0 curve, which is just 0. And so this is greater than or equal to 0 was the conclusion I left out. You with me?
I am with you.
Okay. Let's also consider if you had a case where, I think I'm going to do this down here. Say f was some curve down here. Whoopity-doo. Here's f, a to b. And g is some curve that's below it. G is below f. I could do this in the first quadrant, but then that's the easiest one. People then can't do the hard ones, all right? Now, what do you know about the integral of f? It would be negative for this picture. How would it relate to g generally? More or less? Less. It is more. It is more. Here's why. If f of x is greater than or equal to g of x, then it must be true that if I integrate both sides, that the integral of f must be greater than the integral of g. Now, the picture seems to say, wait a second, isn't f, what do you think? Did you say f is less?
I said it.
Oh, it's not less, it's more, okay? This integral, say this area for red, couldn't it be something like maybe negative 2?
Yeah.
What could g be then? Just throw something.
-4.
Negative 4, which is more, negative 2 or negative 4?
-2.
Negative 2 is greater than negative 4. Okay, surely that would be the same for up here. If this is f and this is g, then the area under g would be less than the area under f. All right? Wouldn't matter if it was first quadrant, second quadrant, third quadrant, fourth quadrant. All right? That's why you don't trust your eyes every time. You trust the calculus. It never fails you. Okay? Finally, L is a lower bound. U is some upper bound. I am telling you that f is some curve that on that region is always less than u and always greater than L. Okay, that curve is always riding between some upper bound constant and lower bound constant. You down? Now, if we talked about the area, then under F, then let's talk about how the area would be bound. Let's, again, start here. The integral from A, let's start with what's given. What's given? That F is between
L and U.
L and U, all right? We want to talk about the integral, or the area under. So to integrate, I must integrate L. Would you write that as L dx, the integral of f dx, and the integral, well, these should be equal to u dx, all from A to B. Okay, now, the middle is what we're looking for, so we're going to just leave this untouched. But what is the left side? What's the antiderivative of L with respect to x? What's the antiderivative of 2 with respect to x? 2x. What's the antiderivative of 7? So what's the antiderivative of L with respect to x? Lx from A to B. What's the antiderivative of u with respect to x? Ux from A to B. Okay, if I evaluate at the fundamental with the fundamental theorem, it would be L times B minus A. Less than or equal to the integral, which is less than or equal to u times B minus A. We? Okay. Great. What the heck does that mean with respect to the picture? Okay, well, check this out. This has meaning. Yeah, that L times B minus A is the area of that rectangle. What's the base? B minus A. And what's the height? L. So it makes sense that the area under the blue curve would be less than, or I'm sorry, greater than the green region, yeah? Likewise, on this side, what is U times B minus A corresponding? Yeah, this would correspond to the picture starting to get a little adjusted, but you get the idea. The integral from, or the region under U would be the rectangle with a height of U and a base of B minus A. So surely the area under the blue curve would be between those two rectangles. You with me? Alrighty. Let's do some practice. Some of these are easy, some of these are not so easy. So, check this out. Think about A for a second, and we'll go over it in a minute. And you say it is 2. Okay? Otros? Don't trust your eyes. Trust your calculator. Okay, which of the regions, which of the ideas is at work here? Additivity of regions. One region plus two regions equals total region. This idea here, okay? A subregion plus a subregion equals a total region. Now they're giving you a little rearranged E form. They give you 1 to 5. They give you 2 to 5. And they ask for 1 to 2. So they give you the total, the part, and a part. And they want a part, right? So let's talk about this. Wouldn't we say that 1 to 5 is 1 to 2 plus 2 to 5?
Yeah.
All right, but we want 1 to 2. So what should we do? Subtract. So this is equal to the region from 1 to 5. Remove the region from 2 to 5. And so now we're home free. What's 1 to 5? 10. And what's 2 to 5? And the answer is -2. Okay? Okay. B, what's going on there? They want 1 to 5, which I have, but this has got a 2 in it. What's the rule? You can move the 2 out front. Then do the integral. What is the integral equal to?
20.
And so our answer is 20, yeah? It's not a lot of work, but that little bit of work really slows your mind down to make you process a little slower so you don't make some silly mistake, okay? So writing slows your mind down. How about this guy? What's the rule? You can separate it. 1 to 5. Is the 2 still in an integral when I separate it?
Yeah.
It is. Okay, now the right side is easy. It's given as 10. But what about the left side? It's 2x from 1 to 5. What does that evaluate at? 10 minus 2 or 8. So 8 plus 10 is 18. Okay? Use the rule. All right. What about D? What the heck? They don't tell me anything about -1 to 3.
I've never seen this.
But I have seen this. You have been taught what to do if you have a function within a function. You use you let u equal
X plus 2.
which means du is dx. If x is -1, then u is x plus 2 or 2 more than x. So u is 1. If x is 3 for the upper limit, u is 2 more than that, so 5. The problem then becomes 1 to 5 of f of u du. Now people then say, well, I don't know what to do. It's a u, not an x. Doesn't matter. Same as f of x, f of u. The area would be the same. I mean, if this curve is what it is, then if I call it x, there's the area. If I call it u, there's the area. If I call it z, there's the area. Doesn't matter. X, u, it's the same. And so it is 10. All right. 5 to 2. What the heck? They switched the limits. What should we do?
Well, we did, right?
Negating 2 to 5. What is 2 to 5? 12. So our answer is negative 12. All right, when they switch the limits, or when we switch the limits, it's the negation. Skip this one. Skip that one.
Oh, let's go.
Okay, let's keep going. We're not going to get to questions. You're going to just do all your questions tomorrow, so don't worry about some homework questions. Let's just keep going. All right? 2 ideas at a time. These will require you to put 2 of the definite integral ideas together. Let's go with this guy. What do you do first?
Negative
Put the 2 out front.
Put the negative 2 out front. And then, do we have 1 to 2?
Subtract.
You can subtract. You can say 1 to 5, take away 2 to 5, and then do negative 2. What is I should have changed these so they're different. Wouldn't you agree then that you get 10 minus 12 inside, and so your overall answer is 4? All right? What about, what 2 rules for B? Pull the 2 up front and negate to switch the limits, so it's negative 2 of 1 to 5, and that is negative 2 times 10, which is 20. All right, cool. What about this? Oh my gosh, it's a mess. What should I do?
Oh, pull it out. Split it up.
Wait, no, it's 0.
Look over. What? It's 0 life.
Because it's D.
Yeah. Okay. I'm looking too far.
Thanks, guys.
All right. D. What about D? Split it up. Okay, so the integral of x from 2 to 10 and the integral of f of x over 2 from 2 to 10. Okay. What about the first one?
Squared from 2 to 10.
X squared over 2 from
2 to 10.
2 to 10. So that is 1 half of what? 100 minus 4. I pulled the half out front. So what do you get?
48.
48. I agree. Okay. I guess we could have kept the half there. That was no idea. All right. What about the other part?
U sub.
U sub. Okay. So what are we going to let U equal? What's du? 1 half dx. Isolate the dx. The dx is 2 du. Change the limits. When x is 2, u is x over 2. So
4.
x over 2. So
1.
1. When x is 10, u is x over 2. So 5. So the problem becomes something like from 1 to 5 of f of u times 2 du. And what will that come to? When I pull the 2 out front and replace the integral, 2 times 10, so 20. So our overall answer is 68. Okay? Scratch F and G.
Yeah. What's up?
Okay? What about E? What about E? Negate 1 to 2. And we know 1 to 2. We've already done that several times. What's 1 to 2?
4.
I think it's negative 2, wasn't it?
Yeah. That's what I mean.
So it is 2.
No, because the thing, it's only 2.
Yeah, we had a 2 out front. The actual.
Oh, you are all right. You are all right.
Okay. Try that free response practice on your own.
I'm gonna go town. So if you're so impressed with my town, I'm not gonna give you a 10.
Good morning, Dublin Jaguars. rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Paul, the female student athlete for November is Emily Belmonte. Emily has been a part of the Green Mountain Gymnastics team now for 2 years. Emily is a 2-year varsity starter, and this will be her second year lettering. She is a strong leader within our team, and her teammates notice her determination and effort in everything she does. She played a huge role in her second place team finish at state last year and has come back even stronger this season. She will be one of the top state competitors on the state team at the beginning of November. Emily played fourth on bars and second on beam last season and was first team All-State. This season, Emily was awarded first team All-Conference and All-Around in Jefferson County. She gives 110% to her routines and teammates every single day and is one of the leading scorers for the Rams. Emily is able to manage her school and gymnastics at the same time and continues to improve in everything that she does.
You got B, boy?
Emily was nominated by Taylor Claire Green, Mountain High School Gymnastics. The male student athlete of the month for November is Will Thompson. Coming into the 2019-20 school year, Senior Will Thompson has spent the last 3 years as part of the Jaguar soccer and basketball program. This fall season, he was elected the team captain for the varsity boys soccer team and was excited about the upcoming season with his teammates. But after just 2 games, Will was injured and unable to compete this season. However, he stayed part of the team and cheered on his teammates at every game. It was during this time he found out he was pretty good at kicking the football, and after it would be okay to kick a football from his dogs. Will became the Jaguar